In this chapter, we will be studying radical and absolute value functions. In this lesson, we will introduce absolute value functions. And we start by looking at the definition of an absolute value.
Hi everyone. So in this particular lesson we're going to introduce a new idea, okay? One that you probably haven't bumped into prior to this point here, unless maybe it was brought up in a science class. But we're going to take a look at absolute value, okay? And so what the absolute value is of, let's talk about numbers specifically to start off with. The absolute value of a number is the distance that that number is from the origin, okay? Without respect to which direction you got to go to get there. So for example, when we say to the absolute value, when we ask for the absolute value of 5, the answer is 5 because the number 5 here is 1, 2, 3, 4, 5 units away from the origin, from 0. But just like the absolute value of -5 is also 5 because -5 is also 5 units away, 1, 2, 3, 4, 5 from the origin. Okay? And that really is the best definition of the absolute value. You're going to, in maybe different context here, people might say, well, it just makes things positive. It just makes things positive. Yeah, it does. But that's maybe not the best overall way to approach that. You should really consider it the distance that something is from the origin. You will see a similar sort of notation used in later forms of mathematics, and this idea of just making things positive really doesn't make sense there. Okay, you really want to think of it as this distance thing. Now, the symbols that we use 2 vertical bars, okay, like this. So this right here, this is the absolute value of 5, and the answer to this is it's 5, just like the absolute value of -5 is going to be 5. So, again, this is a little bit new. Something that you should know about that is these vertical bars, okay, if you're going to think about it in terms of bed mass, okay, order of operations, the vertical bars essentially are going to be a form of parentheses, a form of brackets, okay? So notice with square brackets you'd have the little lines in there, okay? You make these little square brackets here. With the absolute value symbol, you simply don't have those little horizontal bits to them. It's just the vertical lines there, okay? But again, they would come first. You would evaluate the absolute value, or you would do whatever's inside there first, I should say. Evaluate whatever's inside here first, then take the absolute value of the result that you get. Now on your calculator, I want you to see where this occurs because you should know this. So on your calculator here, if you want to access the absolute value, for most of you, if you're going to be working with the Texas Instruments here, you would press your math button, and when you move over to num, it's the very first option that you've got there, okay? So it looks like ABS with a parentheses there. Now on my calculator, when I press enter, it gives me this absolute value that gives me the 2 vertical bars. So if I were to type in -5, whoops, okay, maybe use the arrow to get out of there. When I press enter, the result is 5. For some of you, you're going to see that what it says here is ABS bracket, and then you got to put whatever the value is inside there. So ABS with parentheses around it, it does exactly the same thing. Okay, so that's where you would find it on the calculator. Rules for the absolute values, okay? Essentially, it boils down to this really easily here. If a number is positive or 0, then the absolute value doesn't do anything to it. There's no change. It is what it is. Any positive number is giving you, without changing it, is really giving you its distance from the origin. So the absolute value of 2 is 2. And so the way we handle that is the absolute value of x is x by definition, if that is true. This has to be established as true first for this relationship to be true. On the other hand, if you've got a negative number there, okay, if the value here is negative inside, then the absolute value is simply going to give the positive, okay, because distance is always measured in positive units. Okay, negative tends to indicate a direction. If we're not interested in the direction, we're just interested in the magnitude. Okay, and for those of you that have taken this in science, you're going to recognize the vocabulary I'm using there is you would have seen it in a discussion of vectors. Okay, we're just talking about the magnitude. So I would drop the negative there. So if x is less than 0, then if you've got a negative x, and actually this is probably not the best way to write that. It would probably makes more sense to say it like this. If x is less than 0, Okay, so if x is already a negative number, then the absolute value of that is going to be negative x. Now, that might come across as a little confusing, but let me just do an example here first. In fact, let's use the example that we started here. So we're going to take the absolute value of negative 3. Now, negative 3, okay, is negative. Okay, this is already less than 0. The number inside the absolute value is less than 0. I have to establish that first before I can move on to the next step. I've seen all sorts of students get confused at this point in the discussion of absolute value because in your head you get into your mind, it's, well, I just make things positive. I just make things positive. And then all of a sudden I throw a negative in there. Okay, and I got to explain where that's coming from. But it's almost like a little step in a computer algorithm. I have to look inside here and establish whether what's inside is positive or negative first, and then I do what's required of me, what's next. If what's inside there is positive, I simply write it, I don't do anything. If what's inside is negative, then I rewrite it, but I put another negative in front. Okay? If what's inside is negative, I write it, okay, I rewrite it there, but then I put another negative in front, and the negative of the negative makes that a positive 3. That is why that negative is there. The assumption is, and this is going to be hard for some of you, but you got to listen to me on this one. The assumption here is at this point that x is already negative. So I'm putting another negative in front to change that back into a positive. Now, if that's not confusing enough, okay, we're introducing this new form of notation. We're going to introduce at this point here another form of notation to help explain this new form of notation. And this is what we're going to do here is we're going to introduce something called, okay, so I'll read the sentence here. The definition of an absolute value is a two-part definition, and it is expressed as a piecewise function. Now, this is an incredibly powerful tool, and I'll be honest with you, I really didn't appreciate how powerful this idea of a piecewise function was until I went back and did some more education, and I took some courses in what we call analysis. Man, it's just such a powerful tool for helping us understand different relations, different functions. So what a piecewise function is when you use these parentheses here, and you identify two different functions together, or more, but for that matter. But you also have to identify where along the x-axis that these definitions hold. Okay, so I mean, if I could give an example here that might make sense, and I'm probably going to regret using this one, but let's talk about the drinking age in the provinces of Alberta and Saskatchewan. Now, there's a special town called Lloydminster, and Lloydminster ends up right on the border, okay, between Alberta and Saskatchewan. So now over here in Alberta, okay, the legal drinking age is 18, but in Saskatchewan it's not, it's more, and at one point in time it was 19, just a year difference there. So the rule applies that the legal drinking age is 18 until you hit that line. And once you're over that line, it's slightly more than that, okay? Now, I don't know if it's changed in Saskatchewan at all, but that's at one point, that's what it was here. So in Lloydminster, this border city here, once you cross that line, if there was a restaurant over here and a restaurant over here, okay, if you're 18, you could drink here, you couldn't drink there. Couldn't drink alcohol there. That is in essence what's going on here, and I apologize if that's not the best example to use here, but as soon as I started saying it was the first one that came to mind here. It's the same sort of thing here. The absolute value of x, this notation right here, is by definition just x as long as the value of x is greater than or equal to 0. So here we are along the number line. Here's the 0 line. Okay, if I choose something from here over, okay, the rule is that it's just going to be x. But if I choose a value of x over here and plug it in, then it's this rule. Then it becomes negative x. So there's this little fence, if you will, this barrier in between these two definitions. Once I hit 0, the rule changes. Okay, and that's what this is saying. So I identify what the rule is and where the rule applies. Now, by the way, where the rule applies is always going to be horizontal. Okay, it's always going to be some relationship about x. Okay? Now, what the rule is going to tell me how I behave vertically, but this over here is telling me where it occurs horizontally. Now, you're going to have to probably see a few examples of this to really appreciate what's happening here. So anyway, so now what we're going to do is we're going to take a look at some examples here, and hopefully we can really make this crystal clear. It really is a very, very simple idea, and I when we get into this, we're going to start doing some things here, and I recognize that some people can get a little bit turned around with this, but I need you to kind of go back to this idea that we're always just finding the distance to zero, okay? And so that is a very, very simple idea. It's just that sometimes how that plays out in application ends up becoming a little bit more difficult, okay? So don't beat yourself up if you're having some problems. Just be a little bit diligent with this. Take it slow. Hopefully this will make sense. Okay, for the next few questions, we're just being asked to evaluate the following. So just say what these are equal to. So for question 1, we've got the absolute value of 7. I look inside, I recognize that this is positive. Because it's positive, the absolute value doesn't do anything, it remains positive. So 7 is 7 units from the origin. Negative 8. Absolute value of negative 8. Well, I recognize that negative 8 is less than 0. So what I'm going to do is put a negative in front of negative 8. It's just an if-then. If I see that this is less than 0, then I put a negative in front of it. And then the two negatives cancel and it becomes positive 8. Now, I'm hoping, obviously, that you can get through that a fair bit quicker than what I just did. I'm hoping that you don't actually have to think it through like this, but to start off with, that's not a bad way of doing this. Absolute value of negative 13.3. I recognize that what's in between the two absolute values is negative, so I'm going to put a negative in front of that, and that's going to, the negatives are going to cancel. It's going to make this positive, so 13.3. Then we throw this one into the mix. Now, this one is honestly meant to be a little trickier, because right now I've got a negative in front of an A here, but the thing is, I don't know if A is positive or if A is negative. I don't know. Now watch this. If A is positive, let's say greater than or equal to 0, then the absolute value of negative A, now think about this. If A is greater than 0, so for example, let's say A is 5, then this becomes the absolute value of negative 5. So what happens here is this would end up becoming negative of negative A, and we would just get A. Okay, that's assuming that A is already positive. But if A is negative, then we get a weird sort of a situation here. Okay, so if A is a negative number and I put a negative in front of it, so let's just say, for example, that A is negative 5. So this is negative 5. But you threw a negative in front of that. So this is the negative of negative 5. So, okay, so bear in mind, when I say negative 5, when I say A is negative 5, I'm not referring to this negative. I'm saying that A is a negative number all on its own, and then I'm putting another negative in front of it. Well, that actually makes that positive, in which case, what happens here is the absolute value doesn't change it, and so it stays as negative A. So this one here, this question requires a little bit more thought. It shouldn't be just as automatic, okay, because you don't know what A is. I hope that made sense, because I mean, right there, that's where the whole tricky bit of this thing comes from, is being able to think it through in that kind of an abstract sense. Okay, let's take a look at another one here. It says leave your answers in exact form. So now watch this. The absolute value of 5 minus pi. Now, I said this earlier. The absolute value symbols, in terms of order of operations, they fill the position of brackets. So I'm going to have to do what's inside the absolute value here first before I can see what the absolute value is going to do here. Now, I know that pi is a little bit more than 3. Not much, just a little bit more than 3. So if I go 5 minus pi, I already know that's going to be a positive number. If that's positive, then I know that the absolute value won't do anything to it. And so I just simply write 5 minus pi. Now I want this in exact form, and what I mean by that is don't go to the calculator. And at this point here, is only the next possible step that I could do here, to plug that into the calculator to figure out what the decimal value is. But I'm not being asked to do that. I want to stop right there. So the answer is 5 minus pi. For this one right there, pi minus 4, well, pi, again, is just slightly bigger than 3. So pi minus 4 is going to be a negative number. I already know that that on its own is going to be negative. If it is negative, then I put a negative in front of it. It's just an if-then. But now, I'm going to simplify that. So I'm going to make that negative pi plus 4, or 4 minus pi. And so the answer to the absolute value of pi minus 4 is it's going to be equal to the value that I get when I go 4 minus pi. There's my answer. All right, now let's make it a little bit more complicated by throwing more stuff here. Now bear in mind, every pair of bars there's your absolute value here. So now let's figure out what's going on inside of these things first, because remember, with brackets, you always do what's inside first. So 3 minus 5 is negative 2. 2 minus 4 is negative 2. 5 minus 9 is negative 4. Okay, so now in every case here, what ended up happening was I ended up getting negatives inside the absolute values. Well, those absolute value symbols are going to throw negatives in front of those. So this will become the negative of negative 2 minus the negative of negative 2 minus 3 times the negative of negative 4. I got a lot of brackets going on there. And I know some of you have probably already been able to jump to the answer here, but I want to make sure that for those of you that are a little bit more uncomfortable with this, that you can follow me what I'm doing here. So now that's going to become positive 2. Now I've got 3 negatives in a row here. Those 2 negatives are going to become a positive, so this ends up becoming negative 2. Those 2 negatives are going to cancel out, so I'm going to get negative 3 times 4. Well, 2 minus 2, they cancel. Negative 3 times 4 is negative 12. So my answer here is negative 12. Now, that might seem a little weird at first because you're thinking, these are absolute values. Shouldn't everything become positive? But the absolute value only gets rid of the negatives, whoops, you can't see that show up in between them. When there are negatives between the absolute values themselves, not within an absolute value, but between them, then it is entirely possible that I can get a negative result at the end here. And that's exactly what happened. These two canceled, but that negative 3 made the entire answer their negative. Okay, let's take a look at another one. Okay, so same sort of thing, just a little bit more complicated. Again, I'm going to look for those pairs of symbols so I know what's going on here. This is going to become the absolute value of, okay, well, 3 squared is 9, negative 4 plus 9 is 5. That negative is the in between them. This is going to be 1 minus negative 3. Well, 1 minus negative 3 is 1 plus 3, so this is going to be 4. And then here the absolute value of, well, 5 minus 8 is negative 3. Okay, so now I look at what's inside here. Inside the absolute value is a positive, so the absolute value does nothing to it. Here, the value inside is positive, so the absolute value does nothing to it. That negative is in between two sets of absolute values. Don't get confused by that. The absolute value can't do anything to it because it's not inside. But here, it is inside. So this is going to be plus. What that absolute value is going to do is it's going to put a negative in front of that negative. So now what I've got is 5 minus 4 plus positive 3. So 5 minus 4 is going to be 1 plus 3 is going to be 4. The answer to this one's going to be 4. Okay, and I believe we've got one more example in this little section right here. And let's just zoom out a little bit. Okay, so what this question says is, while traveling through an unfamiliar town, Rudy proceeded to find the town's famous coffee shop. He went back east and forth west many times before finding the shop. What was the total distance traveled if the blocks he traveled are represented below? A positive number indicates east, a negative number indicates west. Okay. So now what we're interested in here is, again, the total distance that this guy travels here. So 2 blocks forward, 8 blocks backward. Now, this is not a vector question. This is not like a physics question where I'm just interested in how far has he gone from his starting point to the end point? What's the displacement there? I want to know, like, if you're looking at the odometer in the car, how far has this guy traveled? So he's traveled 2 blocks here plus 8 blocks. So what we're going to do here is we're going to take the absolute value of each one of these things just to get the distance without reference to the direction that they're going here. So this is going to be 2 plus, and then we take the negative of that to make it positive. Because the 12 is already positive, I don't need to do anything to it. And then I'm going to make the 10, the negative 10, positive. So this becomes 2 plus 8 plus 12 plus 10. So 2 plus 8 is 10, plus 12 is 22, plus 10 is 32. So when all was said and done, if you were to look at the odometer at the end of this, who is this? This is Rudy. Rudy will have traveled 32 blocks.
Now we will take some time to look at the absolute value function.
All right, so now I've described for you what the absolute value function is, what it does. Now I want to do take it to the next level here, and I want to help kind of enhance your understanding of it a little bit more by helping you see it. Okay, one of the greatest things that ever happened in mathematics was the development of the Cartesian plane. Okay, so it takes mathematics from being not just this set of rules, but now we can almost develop this instinctive knowledge of what's going on, kind of a deeper knowledge by understanding what these things look like. So we're going to take a quick look at what the absolute value of x looks like when you set y equal to that. Okay, so we're going to create a bunch of points here where the y coordinate will simply be the absolute value of the x coordinate. So now we're going to start off with comparing them. So we're going to start off with y equals x. What does it look like if y is just equal to x? So, and that's a pretty easy chart to make here. So -3, -2, -1, 0, 1, 2, 3. If y is exactly the same as x, I don't have to do anything. And what that looks like here when you put those all together is you just get this diagonal line here. Okay. That looks like this, and you just connect the dots. Perfect. So that right there is the line y is equal to x. Now, y equals the absolute value of x. What that's going to do is that's going to take the x coordinate here, and remember, if the x coordinate's negative, I mean, the long and short of it right now is to make this easier to work with, it's going to make that positive, right? So if there's a negative in front, it's going to drop that negative. So -3 becomes 3, -2 becomes 2, -1 becomes 1. Then once we get to 0 and positive values, the absolute value isn't going to do anything to that. Now what's interesting about this is that when x is greater than or equal to 0, the graph, the absolute value, doesn't do anything. It's exactly the same. So when x, now let's just think about that, when x, well, here's 0. When x is greater than or equal to 0, so for this portion of the graph right here, this is the same thing. It's exactly the same as that line y equals x. But when x is less than 0, then all of a sudden it changes, and what's going to happen here is this is when x is less than 0, all of a sudden the signs change. And so instead of going down to -2, or let's say -1, it's going to pop up to +1. Instead of going to -2, it's going to go up to +2. -3 is going to end up at +3. And that's going to continue to work like that all the way up here. And so we get this thing right here. And I'll just make this as thick as the other one. And that, everybody, is what the absolute value of x looks like. It's got this very, very distinct V shape to it. Okay? You've seen parabolas. Parabola's got that kind of a U shape to it. Okay, you got a straight line. This is what the absolute value function looks like. And so now let's go through and let's just talk about some of the features of the graphs. When you talk about y equals x, the domain is going to be all reals. The range is going to also be all reals. The x-intercept is 0 and the y-intercept is 0. Now that's just of that straight line that came down like this. Now when you throw the absolute value over that, the domain is still all reals. There is no number out there that you cannot take the absolute value of. The only thing the absolute value is concerned with is whether or not a number is positive or negative, or zero, but we're going to associate zero with the positive numbers. That's not 100% necessary to put it with the positives. You could easily put the zero with the negatives. It doesn't matter. This is just a choice we're making right now. But anyway, whether it's positive, negative, or zero, though that covers all numbers. Yeah, there we go. The range, however, notice that the absolute value function drops down, hits zero, and then goes back up. It does not extend below the x-axis. And that actually makes perfect sense because the absolute value makes these things positive. So then y is going to be greater than or equal to zero, because when we hit the origin, it does actually hit zero. The x-intercept, it hits the x-axis at zero. It also hits the y-axis at zero. So the only thing that really changed right now in terms of these properties was the range. Now visually it's different for sure. But something to note here is that when we are dealing with positive values of x, it's exactly the same as the line y equals x. When we're dealing with the negative values of x, it's a different line altogether. Now notice that the original y equals x has a positive slope, and then here this one actually has a negative slope. Just some interesting properties. They're really, really interesting. Okay. Now there's a little bit of a description down here, and I want to link this down. I want to kind of push us towards the piecewise definition here. So all of the y values that are negative, they became positive. Basically, they reflected. Okay, they reflected in the x-axis there, and we get this V shape. And what they're saying right here is essentially what I just went through. If x is greater than, okay, this is where x is greater than or equal to 0. Notice that what we're dealing with here is the line y equals positive x. It's exactly the same as y equals x. Completely identical. But over here, when x is less than 0, in that section right here, okay, and remember what I was getting at before. This is like driving from one province to the other. The rule changes when I go from one province to the other as I'm driving horizontally across. I'm not going vertically. Okay, I can't drive vertically I can't drive north and south. If I'm in Edmonton, I can't drive north and south and expect to get to Saskatchewan there. That's just not going to work. But I can drive horizontally. It's the same thing here. Over here, the rule is basically, it's essentially the same graph. It's just that this one's been reflected over. It drops down. This has got a negative slope. That's negative x. Okay? So we've got two, to create the overall function here, the absolute value function, we've got two different functions that we are going to piece together. And where they piece together, the joint between them, okay, where they join is where x is equal to 0. Anyway, this allows us to create this particular function right here. Y, in this case, the absolute value of x, which is y here, we're going to write that as just x if x is greater than or equal to 0. And we're going to write it as negative x if x is less than 0. This is exactly what this information is right here that we're saying. So this function right here can be written in one of two ways. I could write it as the absolute value of x. That is the simplest way of writing that, the absolute simplest way of writing that. Or, to make this a little bit more, I want to say user-friendly, because that may be misstating it there, but relating this back to tools that you have been introduced before, I can take this thing, which is this, again, the simplest way of writing this, but maybe it's not the simplest way to understand it. Maybe it's easier to break this up into two simple expressions, just x or negative x, and we'll piece those together. So maybe it's a little bit more complicated to write, but I'm writing it in terms of much more simple functions there. Okay? Anyway, I hope that makes sense here. So now what we're going to do is we're going to take a look at some examples. Okay, let's take a look at the graph of, ultimately we're looking at the graph of the absolute value of 2x minus 8. But we're going to kind of work our way there, and then we're going to start talking about how you can rewrite this in terms of a piecewise function. But to start off with here, let's just fill this in. So 2x minus 8, what does that look like? Well, first of all, I can start with using the table of values, and then what I'll do is I'll just talk about it in terms of the slope-intercept form. But if I plug negative 1 into that, my y value would be negative 10. 0 is going to get me negative 8. 1 would be negative 6. 4, notice 4 would be 0. 5 is going to give me 2, and 6 is going to give me 4. Okay, so now I can plot those points for sure, or what I could do here is recognize that this is going to be a line that has a y-intercept of negative 8. I'll come over here and draw that down, negative 8. And it's going to have a slope of 2. Okay, so when I go over, okay, now bear in mind this is where 1 is. When I go over 1, I'm going to go up 2. So then it's going to go there, 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 and so on. So this is going to look, whoops, something like this. Okay, so there's my line, y equals 2x minus 8. And again, you can think of that as either just plotting those points and connecting the dots, or as using the slope-intercept form. Now, the absolute value is going to throw if it's negative inside there, it's going to throw another negative there. So it's going to make this positive 10, it's going to make this positive 8, it's going to make this positive 6. If the value inside the absolute value becomes positive or 0, then the absolute value leaves it alone. So 10, 8, 6, 0, 2, 4. Now, the fallout of that is, okay, notice down here for these guys, when x is 4 and larger, it's exactly the same. So what's going to happen here is at 4 and larger, okay, when x is greater than or equal to 4, and notice that 4 is that x-intercept. Oh, look at that. That's the x-intercept. To the right of that, well, this is positive. It's above the x-axis. So the absolute value is going to leave that the same. All of those points, those are going to get overlapped. Now, when x was less than 4, in this spot right here, x is less than 4, the absolute value changed all of the signs. Negative 10 became positive, negative 8 became positive, negative 6 became positive. So these points down here flipped up. Like that negative 8 goes up to positive 8. Okay? Now here that negative 10 goes to positive 10. This negative 4 here became positive 4. And so we could connect those dots right there. I'll make that thicker again to illustrate that that's the absolute value. And there's that nice little stereotypical V shape. So then we're left with this is y is equal to the absolute value of 2x minus 8. Okay? So let's talk about this again here. The domain. What was the domain? Well, for the line, it was all reals. The range was also all reals. Okay? Remember, this is for the line, but this is before the absolute value. The x-intercept here was where x was, x was equal to 4. Whoops. Oh my goodness, what's happening? 4. And the y-intercept was negative 8. Now, the domain of the absolute value was exactly the same. Okay? And you're going to see that that domain's not going to change here. The range, well, once again, notice that it drops down, or maybe drops down this way to the x-axis, hits it, then bounces back up. So the range here is going to be where y is greater than or equal to 0. Okay? And then the x-intercept here is going to stay 4. It's going to still hit the x-axis at the same spot here. But notice what it does to the y-intercept. The y-intercept used to be negative 8, but now the absolute value keeps that function from going into quadrants 3 and 4. It bounces it back up. So that y-coordinate that was negative became positive. Now that's maybe a little bit confusing to people because you might think, well, wait a minute, the absolute value is around the x-coordinate. That's true, but remember that the y-coordinate is, okay, the y-coordinate is the absolute value of the x. So the y-coordinate, bear in mind that when the result here originally, when this result here became negative, then I took the absolute value of it. Basically, those absolute values were the last things I did before I got the y-coordinate, so it took that negative 8 and went one more step and made it positive, and that's why it jumps back up. Okay, so anyway, that's what the graph looks like. Now we're going to take a couple moments here and we're going to start talking about that equation a little bit more.
Now finally, we're going to introduce a procedure for writing the piecewise function.
Okay, so now we want to talk about writing the piecewise function that corresponds to an absolute value function. Okay, now this should be a very easy, very natural thing to do based on the work that we've just done leading into this. So first of all, what you might want to do here is graph the function and find the x-intercept. Now, that x-intercept is super important, okay, because it was the invariant point. The x-intercept, remember here, the x-intercept is always going to be the same, okay, between the function with the absolute values or without, it's the same. It was true over here as well. Whoops, sorry, you can't see that. The x-intercept here was the same with the function that didn't have the absolute value, the one that did. That'll always be the case, okay? So the first thing we want to do is find that x-intercept. That's going to be the boundary between the two functions that we use. So if you look up here, notice what we did here is the x-intercept here, okay, is what separates the one part of the absolute value function from the other part. Okay, so now, whoops, sorry, I don't know why I wanted to flip that. So now the next thing that you're going to do here is going to determine which part of the graph is already above the x-axis. That's the part that stays the same. Okay, that is going to be related to the positive part of that function, because remember the absolute value doesn't change that part, leaves it alone. So we just leave it like that. Then the other part of the function, the part that's below the x-axis, that's the one that becomes the negative case. And so all we really got to do is multiply that part of the equation by -1. But as we stated before, with the piecewise function, then you got to have your little comma and just identify the intervals, okay, the x intervals on the graph where those functions applied. Now, that probably doesn't make a heck of a lot of sense right off the bat here, so we're going to have to do some examples of that so you can see that. All right, so the first example we're going to work with here is actually the one that we just did at the top of this page here. We're going to find the absolute value of 2x minus 8. Now, let's slide up here. Here's where that graph was. Now, I want you to notice, first of all here, that when I went to my table of values, remember, this part right here on the table of values, wow, I'm bad at doing that, this part of the value did not change. This didn't change at all, and this was where the x values were greater than or equal to 4. Up here, these were the parts that did change. This is where x was less than 4. So that translated down to that. So what I'm going to have here in my piecewise function, I'm going to have two different functions here. This one is going to be where x is greater than or equal to 4. This is going to be where x is less than 4. Now, arguably, you could put the or equal to here if you wanted, if you really wanted to, but that's just not the convention that we have adopted here. Okay, and so I just wanted you to know that that's not an absolute. That's not set in stone. Now, let's go up here and take a look at this. This part of the function right here, okay, this is exactly equal to the part of the function that didn't have the absolute value in it. That's the part that was equal to 2x minus 8. When x was greater than or equal to 4, the absolute value was equal to that original function right there. So down here in my function, when x was greater than or equal to 4, that is exactly the same as 2x minus 8. There was no change. Now, how do I make the change for the second part right there? Well, what you do, and this goes right back to the very beginning, when we first started to define this, if the part that's inside here is negative, what do you do to it? Well, you put a negative in front. You would put a negative in front. That's it. That's all you got to do is you slip another negative in front of that. And so now we might simplify this and write this as 2x minus 8 when x is greater than or equal to 4, or negative 2x plus 8 when x is less than 4. So two different functions, but two different intervals over which they apply. Okay, let's take a look at another example. Okay, we'll zoom in a little bit here. So question 2 says, without sketching, express the following as a piecewise function in simplified form. Okay. Well, first of all, just drop the absolute value. Y is equal to x plus 2. Now, it says without sketching here. Now, so what we mean by that is I'm not going to draw a perfect sketch, but I am, however, going to give me a quick little little bit of a sketch so I get a sense of what this looks like. I know that this is going to have a y-intercept of 2. It's going to slide down like this. I know it's going to have an x-intercept of -2. Okay? When x is greater than -2, it's going to be the exact same function, x plus 2. So then the exact opposite, so that's up here. For this part right here, it's exactly the same. This is where x is greater than or equal to -2. Over here, this is going to be where x is less than -2, and all I'm going to do is I'm going to throw a negative in front of everything that's inside the absolute value, and so this is going to look like this. X plus 2 when x is greater than or equal to -2, negative x minus 2 when x is less than -2. Oh, you can't see that, sorry. Over here, the absolute value of 15 minus 3x. Oh, okay. Well, again, I'm going to give myself just the most basic sketch here. If you drop the absolute value here, that's going to have a y-intercept of 15. It's got a slope of -3, so the original function drops down like this. It is going to hit the x-axis there at 5, so I know that 5 is going to be my x-intercept. Now here, this is where x is less than or equal to -5, sorry, positive 5. Wow. Sorry, I don't know why I threw the negative in there. And this is going to be where x is greater than 5. Now notice when x is less than 5 in this interval right here, the absolute value, okay, I'm going to draw that V shape here, but the absolute value is exactly the same. It overlaps that function 15 minus 3x. So the absolute value, or the piecewise function, is going to be 15 minus 3x when x is less than or equal to 5. And then I'm going to throw a negative in front, whoops, not comma, 15, sorry, negative bracket 15 minus 3x when x is greater than 5. Because up here, this is where they split. Now, if you multiply that negative through, then our piecewise function is going to look like this. 15 minus 3x when x is less than or equal to 5, negative 15 plus 3x when x is greater than 5. Okay? Now, I'm going to be honest with you. I would almost prefer if you went one step further. If you change these around and made them a little bit prettier by pulling the linear term up front, so made this negative 3x plus 15 when x is less than or equal to 5, made this positive 3x minus 15 when x is greater than 5. That just looks better. It doesn't mean that this is more right than this one. They're both fine. That just looks better. Okay, let's do one more here. This guy right here. Again, if I just drop the absolute value and just graph that, that's going to be -3. It's got a slope of 2. So my x-intercept in this case right here is going to be 3 over 2. So when x is greater than or equal to 3 over 2, it's the exact same function. If you drop the absolute values, it's the exact same function. When x is less than 3 over 2, then it's a different function here. So it's exactly the same, no difference if x is greater than or equal to 3 over 2. However, as soon as x is less than 3 over 2, then the absolute value is going to put a negative in front. And then the next thing we should do is distribute that negative. And that becomes negative 2x plus 3 if x is less than 3 over 2. Now, to summarize what's going on here, what you should be seeing here is notice that my intervals here, they always break. We're always separating at the x-intercepts. It's always one side or the other. Okay? If the original function is positive, then the absolute value does nothing to it in that interval. If it's negative, if the original function drops below, we simply put a negative in front and then multiply it through. That's it. That's all we're doing. Now, let's take a quick look at another question here that's asking us to simply graph it. Now, if we're going to graph the absolute value based on this right here, I want you to understand how very simple this is. The absolute value basically takes things that are below the x-axis and moves them above. Essentially, the absolute value does not want anything to show up in quadrants 3 and 4. only in quadrants 1 and 2, because that's where we are above the x-axis, that's where we're positive. So what would happen here is this point right here below the x-axis would jump up. Because it's 2 below, it's going to jump up to 2 above. Because this one right down here is 4 below, it's going to jump up to 4 above. And so what will happen here is this part is going to remain. That part was okay. And then this part here that was negative is going to flip up. And we kind of get rid of that. That's what the absolute value, this is y equals the absolute value of f of x. Take a look at the next one. Similar sort of thing. This time though, because this is the portion that stays above, that portion stays there. Sorry, that's the portion that's above, so it stays there. This one down here, when x is 0, this was at negative 3, that's going to jump up to positive 3. And then over here, this is going to go down. This was at, what is that, negative 6. This is going to jump up to positive 6. And so now I can connect these like this. And again, this part here disappears. It's no longer part of it. This right here is your absolute value of f of x. Over here, a similar sort of thing, just a little bit different here. This function here, because this is the portion that's in quadrants 1 and 2, this portion stays. Because this portion here dipped below into quadrant 3, that's going to flip up. So where that y-coordinate there was negative 1 is going to jump up here to positive 1. And I'll just connect the dots here. I don't actually have a lot of graph here, but this part's going to disappear. And so what you're seeing there in bold, that is the absolute value of f of x. So essentially, anything that dips below into quadrants 3 or 4 is going to get reflected over the x-axis into quadrants 1 and 2. Okay, now finally here in this section, what we're going to do is we're going to write a piecewise function that represents each graph here. Okay. Now, we've already got the graphs here of the absolute value of 2x minus 2 here. Bear in mind that at the x-axis, at that x-intercept here, this is where we're breaking this thing up into 2 different regions here. This is where x is going to be greater than or equal to, let's say, what is that, positive 1. This is where x is less than positive 1. So now I just got to figure out here, okay, when you drop the absolute value here, and I think there are a couple of ways you can interpret this. There really are. But I think the most obvious way to do that is if you drop the absolute values, just leave that as 2x minus 2, everybody. That's a line that's got a positive slope. That's this one right here. So when x is greater than or equal to 1, the function is 2x minus 2. Drops it all the way down. Okay, that would be the line that goes down like this. When x is less than 1, then what's happening here is the original function, that 2x minus 2, would have dropped down here. The absolute value is going to flip that over. So in our piecewise function, to show that that happens, we throw a negative in there. Okay, oh, you can't see that. We throw a negative in front of it. And so our piecewise function is going to look like this. It's going to be positive 2x minus 2 when x is greater than or equal to 1, negative 2x plus 2 if x is less than 1. Okay, let's try that again with this one right here. Here, we got the absolute value of 3x plus 6. Now notice that our x-intercept is negative 2, so that breaks this up into 2 different parts here, where x is greater than or equal to negative 2, where x is less than negative 2. Now, this function right here, 3x plus 6, if you drop the absolute values, if you ignore those, you end up with that function right there, 3x plus 6. That's a line that's got a positive slope. That's this guy right here. So that, what I'm saying is that's where the absolute value function overlaps the function that doesn't have the absolute value. So when x is greater than or equal to negative 2, this function is simply going to be 3x plus 6. But when x is less than negative 2, the original function would have dropped straight down, but this function's been flipped over, so what the absolute value has done is thrown a negative in front. And now to simplify that, okay, we will write this as 3x plus 6, where x is greater than or equal to negative 2, and negative 3x minus 6 when x is less than negative 2. Okay? Man, I really hope that makes sense. You really want to spend some time on this, taking it easy, go through this kind of slowly here. These are very simple ideas. Our notation is a little bit complicated, okay? And sometimes in our attempt to break these things up into nice, easy to swallow chunks, sometimes we inadvertently make this more complicated. And I apologize if that's what you're experiencing here. Please take some time to go through some problems on your own.